Every time you stream a movie, send an email, or just scroll through your phone, you're tapping into a massive global network of computer rooms we call data centers. But all that processing, it generates a crazy amount of heat. So today, we're going to dive into the invisible, high-stakes battle to keep the entire internet from, well, literally melting down. Okay, let's just start with this number, 102,360 BTUs per hour. Now that staggering figure, that's the heat coming from just a single high-density server rack. And there are millions of these things running 24/7 all over the world. We're talking about a mind-boggling amount of heat energy. To really wrap your head around that, think about this. An average person just sitting still gives off about 450 BTUs an hour. So do the math. One of those server racks is pumping out more heat than 220 people crammed into the same space. It's just wild, and it really shows you the enormous scale of the challenge engineers are facing. And that leads to the big question, right? This isn't just about things getting a little warm. No, this is about survival. If these components overheat, they don't just slow down, they fail. They can even catch fire. Our entire digital world, everything we do online, depends on finding a really, really efficient answer to this problem. And finding that answer takes a ton of energy. Just look at this. A whopping 35% of a typical data center's insane electricity bill goes straight to cooling and HVAC. That's the second biggest expense, right after actually powering the computers themselves. So you can see a more efficient cooling solution doesn't just save the servers, it saves an absolutely colossal amount of energy. Okay, so how did we get here? How did engineers start to tackle this problem? Well, the journey didn't begin with some super complex, high-tech gizmo. Nope. It started with a really simple, almost elegant idea. Just organizing the air. In the early days, it was basically just chaos. You'd have server racks kind of placed wherever. Cold air gets pumped in, hot air blasts out from the servers, and it all just mixes together in this big, messy thermal soup. As you can guess, it was incredibly inefficient. You'd get dangerous hotspots, servers would fail all the time, and you were just wasting a ton of energy. So pretty quickly, engineers were like, okay, there has to be a better way. The next logical step was pretty simple. Just line up all the servers so they're all facing the same direction. And hey, it was a little better, but it created a whole new problem. The hot air coming out of the back of one row would get sucked right into the front of the next row. It's a problem called short-circuiting, and it was a huge issue. And that problem led to a real breakthrough. The idea that really changed everything, the hot/cold aisle configuration. It's brilliant in its simplicity. You arrange the racks so they're face-to-face in one row and back-to-back in the next. This creates dedicated aisles. You get a cold aisle feeding cool air into the front of the servers and a hot aisle collecting all the hot exhaust from the back. This one simple change was a total game changer for efficiency. But, engineers are never satisfied. Even with this great hot/cold aisle system, you'd still get some of that hot air sneaking over the tops of the racks or around the sides and mixing back in. So the next big step was to take this really good idea and make it, well, pretty much perfect. And they did that by literally trapping the air. And this brings us to the two main strategies they use today, cold aisle containment and hot aisle containment. The goal for both is basically the same. Create an actual physical barrier using panels, doors, even little roofs to stop the hot and cold air from ever mixing. So what's the difference between them? Well, it's a bit of a trade-off. With cold aisle containment, you build a box around the cold aisle. This is super popular for upgrading older data centers because it's cheap and easy to do. The catch? The rest of the room becomes one giant hot zone. Hot aisle containment does the opposite. It traps the hot air, usually in a sort of chimney. This is way more efficient, it's the go-to for new builds, and it keeps the main room nice and cool for the people working there. All right, so we've got these awesome design principles, but how do you actually apply them perfectly in a facility that costs millions of dollars? You definitely can't just guess and hope for the best. Today, engineers test everything, optimize every little detail, all in the virtual world. They're literally designing with digital air before anyone even breaks ground. The magic behind this is a tool called computational fluid dynamics, or CFD for short. The easiest way to think about it is like a weather forecast simulator, but for the inside of a building. It creates this perfect digital twin of the data center, and it can predict exactly how the air is going to move, where the hotspots will be, and flag any potential problems before they happen in the real world. And that right there is why CFD is such a game changer. Engineers can run dozens of different simulations, try out all kinds of layouts, find tiny inefficiencies, and just keep tweaking the design until it's perfect, all virtually. It saves a fortune by preventing huge mistakes, and it means the data center that actually gets built is going to be as energy efficient as it can possibly be. But here's the thing. Our demand for data is just exploding. It never stops growing. And every year, servers get more powerful, which means they get hotter and hotter. So the future of cooling is all about getting more targeted, moving the cooling solution as close as possible to the source of the heat itself. And this has led to some really cool, no pun intended, innovations. You've got stuff like in-row cooling, where they literally put smaller AC units right there in the server rows, zapping the heat at the source. For the really power-hungry racks, we're seeing more and more liquid cooling. I mean, it makes sense. Liquid is about 4 times better at pulling heat away than air is. And then maybe the smartest idea of all? In places with the right climate, some data centers are just using the cool outside air to do the work. So you see, this invisible world of data we all live in, it has a very real, very physical footprint. Our hunger for more data, faster speeds, it's just growing exponentially. And that means the challenge isn't just about clever engineering anymore. It's about the environment. The quest to keep the internet cool is really a quest to balance our digital world with our real one.